So now that you know what the tan ratio is, you can use it to solve for an unknown side length. So in this example, we've got 35 degrees of this triangle. That's our target angle. I'll call it theta. And then relative to that angle, the opposite side is over here at the x, and our adjacent side is 10. So we know that tan of this 35 degrees is opposite over adjacent, which in this case is x over 10. And tan of 35 is just a number. It's just a ratio your calculator can pull up. So we can solve now for x. So tan of 35 is x over 10. We're going to rearrange by multiplying both sides by 10 so that we can cancel the 10s out on the right. Some people also see that as cross multiplying, so they bring that 10 up across the equal sign and to the numerator of the other side, whichever way works for you. That gives us x equals 10 times tan 35. And so on your calculator, you do 10. You don't actually even have to press the multiplication button, just 10 tan 35 equals. And that gives you the number you see here if you round to 4 decimal places. Okay, another example. So we've got our 40 degrees as our target angle. That means the 7 is going to be our opposite side relative to that angle, and x is our adjacent side. I don't know why I wrote side. X is our adjacent side. Okay, and so tan of 40 degrees then would be 7 over x. And then we're trying to solve for x. So a couple ways you can do this. So we can think of this with algebra. Okay, we're trying to solve for x. So let's get x out of the denominator by multiplying both sides by x. That gives you x times tan 40 equals 7, or x's cancel on the right. And then we're still trying to solve for x, so we're going to divide both sides by tan 40. And then we end up with x equals 7 over tan 40, which is what you'll see in the problem down here. The other way to do this, if you want to think of this as cross multiplying, some people like to just interchange these two. So you can always, if you're just dealing with two fractions across an equal sign, you can trade the denominator across to the other side and put it in the numerator, or put the numerator that was there across the other side into the denominator. So you can basically switch the positions of the tan 40 degrees and the x. And then you get the same thing. We end up with x is 7 over tan 40 degrees. So whichever way works for you. And once you calculate that, and punch it into your calculator, round to 4 decimal places, you should get that answer. The other thing we can do with the tan ratio is if we know both the opposite and adjacent side lengths, we can solve for the target angle. So here we happen to know we're going to look relative to angle P. So 3 is our opposite side and 5 is our adjacent side. That means tan of angle P equals 3 over 5. We could convert that to a decimal of 0.6. So that's what they've done down here. Tan of angle P equals 0.6. Now, the way I like to think of this, so we've got tan of angle P equals 0.6. What we'd really like to do is get rid of the tan, though, because we just want to know what angle P is. And so I think of this as taking the inverse of both sides. Tan inverse undoes tan. So if I do tan inverse of tan of angle P, I'm just going to be left with simply angle P. And then I have to do tan inverse of the other side too. So I do tan inverse of 0.6, and that gives me angle P equals, now on your calculator, you're going to have to do tan inverse of 0.6. So on most calculators, it's a second function of the button tan. So like on my calculator, if I hit second function, it takes me into the yellow writing above my buttons. And so that's how I can hit the yellow writing that says tan inverse. But each calculator is different. So if you do tan inverse 0.6 equals, if you round to the nearest one, you get 31 degrees there. Okay, So the following exercises are going to give you practice with solving for side length and for solving for angles. So give them a try and come on back to do them together.